For 2 cosine 4x minus 1, the difference here is that inside our cosine function, we have something other than just an x. It's only going to change one step of our process. So to solve this, first thing I'll do is I'll move the 1 to the other side and divide by 2. So I'm looking for where cosine of 4x is equal to 1/2. That's still asking me where is cosine equal to 1/2 first. And where does that happen? Cosine is equal to 1/2 at pi over 3 and at 5 pi over 3. So the difference here is that instead of having x inside, I had a 4x inside. Okay, we know that cosine repeats itself every 2 pi, so I'm going to add 2 pi in here and 2 pi in over here. Okay, so our last step is going to be, I have that 4 in front. I want to divide both sides by 4, and I'm going to divide everything in there by 4. So I'm going to take the x can equal pi over 3 divided by 4 is pi over 12, and I also need to take the 2 pi in and divide it by 4. 2 pi in divided by 4 is pi over 2. So I'm going to add pi over 2 in. Okay, 5 pi over 3 divided by 4, that's 5 pi over 12. And 2 pi in divided by 4 again is pi over 2 in. Let's think through that in a slightly different way. Remember when we did all of our transformations of our trig graphs? We had the phase, the period of the graph is changing based on that 4. So cosine starts off as a 2 pi period. The 4 in front, we divide our 2 pi by that was our b value. So that's going to make our period only be, instead of 2 pi, it's going to be 2 pi over 4, which is pi over 2. Notice that that's what I'm adding at the end. So if this is, I think, the fast way to do this. But if you get to the end and you're like, man, how often was it repeating itself? Well, it was 2 pi, I'm dividing it by 4. So I'm going to add just pi over 2 intervals instead of 2 pi intervals. So that just means this is repeating itself basically in every quadrant, or really fast when you're graphing it on a xy plane.